In this video, you'll finally learn everything you need to know about trigonometry. Not just how to use it, but how to truly understand it. You've probably heard of sine and cosine. You might even remember SOH CAH TOA from class. But let me ask you this. Have you ever stopped to think what sine and cosine actually are? Because if you think trigonometry is just about triangles, opposite sides, and hypotenuses, you're only seeing a tiny piece of a much bigger picture. Get comfortable and let's dive in. Let's start where everyone starts, with the right triangle. You have an angle, and you define sine as the length of the side opposite that angle divided by the length of the hypotenuse. Cosine is the length of the adjacent side divided by the hypotenuse. That works, but only for angles between 0 and 90 degrees. Because the sum of the angles of a triangle is always 180 degrees, and if we have a right triangle, we already have an angle of 90 degrees. So we can see that the other two angles can't be greater than 90 degrees. What if you want to know the sine of 120 degrees, or even 270 degrees? You cannot draw those in a right triangle. So how do we fix this? We stop thinking in triangles, and we start thinking in circles. Imagine a circle with radius 1, centered at the origin of the xy plane. Now draw a line from the origin at some angle. We will call it alpha, measured from the positive x-axis. That line intersects the circle at exactly 1 point. Then, add a vertical line from that point straight down to the x-axis. You have now created a triangle, a right triangle, inside the unit circle. The x-coordinate of that point is the cosine of alpha. Why? Because the adjacent side of the triangle is equal to x, and the hypotenuse is 1, since we are in a unit circle. So the cosine of alpha is equal to x over 1, and thus it is just x. Similarly, the y-coordinate is the sine of alpha, because the opposite side is equal to y, and again, the hypotenuse is 1. So, sine and cosine are simply the coordinates of a point moving along the unit circle. Let's test this with some common angles. At 0 degrees, the point lies on the right side of the circle, at 1, 0. So cosine is 1, and sine is 0. At 90 degrees, the point is at the top, at 0, 1. Cosine is 0, sine is 1. At 180 degrees, the point is on the left, at minus 1, 0. Cosine is minus 1. Sine is 0. I think you get the point. At 360 degrees, you are back where you started, 1, 0. The values repeat because the point moves in a circle. So if you have any angle and you add or subtract 360 degrees, sine and cosine will stay the same. In math language, we write alpha is equal to alpha plus k times 360 degrees, where k is any integer. In other words, the sine of x is equal to the sine of x plus 360 degrees. The cosine of x is equal to the cosine of x plus 360 degrees. And here is the amazing part. You do not need to memorize this. It is just geometry. Now, angles are not the only way to describe positions on the circle. There's another way. Radians. 1 radian is defined as the angle for which the arc length is equal to the radius. In a unit circle, 1 radian is the angle that makes the curved edge along the circle exactly 1 unit long, the same length as the radius. A full circle is 2 pi radians, because we can calculate the circumference of the circle by the formula 2 times radius times pi, and the radius is 1, so the circumference is 2 pi. Half a circle is pi radians. A quarter circle is pi divided by 2 radians. The triangle method is fine, but it is limited. The unit circle is universal. And if you enjoyed this video, I would really appreciate it if you like it and subscribe to the channel. Thank you for watching.